I'm Chris Brown. I'm the verification manager at BROADCOM in the Cambridge site. I've got lots of verification challenges, but I've only got 10 minutes. So I'm going to stick to two. I'm going to talk about standards in the EDA space. I'm going to talk about IP reuse of IP verification in the SOC space. But just before I do that, I'll give you a little bit of background. A lot of people don't actually know that we exist in the Cambridge site. So just tell you a little bit about what we do, just to give some kind of context to what I'm going to say. So we're an IP and a chip design team. There's about 200 or so of us on site. That's 50 or so in hardware, 150 or so in the software space. So we're a fairly sizable group. And we're part of BROADCOM's mobile product solutions business unit. We do all the multimedia stuff within BROADCOM, basically. Anything that goes in any handheld device, phone or tablet from BROADCOM. So we've done the 3D graphics, the imaging, the displays, all that kind of good stuff. And we're also the home of the Raspberry Pi, if anybody's heard of that. Enough background. So my first challenge, I was actually thinking about this in the equivalent event last year, and I wasn't sure if I was going to bring it up, but I was talking to some people at the TVS formal day, and they were having similar problems that I was, particularly with USIS. I'll get to it in a minute. But I thought I would start with a little bit of history for those of you who are relatively new to the verification space. So I can make the point to work. No, I'll make the point to work. So back in the late 80s, everybody was using directed tests, pretty much. And then in the early 90s, the large IC teams, the PowerPCs, and the x86 guys and the big DSP teams, they started using pseudo-random techniques, assertions, coverage. If you go and look in the literature, things like DAC reports from the early to mid-90s, you'll find all that stuff available in the early 90s. Later in the 90s, you got the commercial tools like SpecMan and Vera. Some of you may remember Rave and Test Builder. There were others around at the time. And in the marketplace, there was a bit of a shakedown. Eventually, SpecMan and Vera were the only really to survive. In the early 2000s, the smaller EDA companies like Veristi and System Science got bought up by the larger ones. Then we got to System Verilog being ratified in the mid-2000s. That was cocked up. So then we had to have the vendor-specific methodologies like VMM and AVM and OVM. And then eventually we get to UVM in the early 2010s. So 20 years from when the original concepts were available, they were published, until we get to a point where we've got a basis for wide adoption in the industry. 20 years. Hands up who could get away with that in their market space. Think of all the wasted time, the wasted training dollars that have been spent at Doulos. I'm sure he's going to try and sell us more training later. The wasted verification IP that was done in all these different languages. Think of all the legacy code that's out there now that could all have been written in one standard language if we'd have got our act together when all this technology was around in the in commercial tools in the late 90s. So my first challenge is to find a different way to work. Collaborative competition is the way I'm talking about it. There's probably a better phrase, but we, the users, we need the EDA industry. We need these people to be competing. We need healthy competition. But we don't want to be locked in by particular vendor-specific methodologies, vendor-specific languages, and APIs into databases. For everybody who gets locked in, there's a whole load of people who are locked out of a particular tool. So this is a really bad thing, in my opinion. And you look around industry in general, you'll find a whole load of places where standardization actually enables marketplaces. There's people in this room from BROADCOM who make the best 3D graphics IP. But we've also got representatives from ARM Mali here. We've got people from Imagination, the Power VR. We've got people from NVIDIA in the room. There are others as well. And we all compete fiercely in the computer graphics acceleration space. We're all fiercely competing with each other. But that whole market is actually enabled by OpenGL. Without OpenGL, we wouldn't have a business to play in. So standardization can work. There are lots and lots of other examples out there in industry in general where the standard actually enables the marketplace and enables people to make more money. Contrast that with verification planning. We don't talk enough about verification planning. If your verification plan sucks, your verification sucks. You'll be late and it will be poor quality. Verification planning is really, really important. Verification planning tools have been in the marketplace for a number of years. People have been trying to sell me them for a number of years. But they're always tied to a particular test planning file format from a particular vendor. One of the valuable things to me is annotating my coverage back onto my test plan. But my test planning tool is tied to a particular simulator. All these tie-ins actually lead to fairly low adoption of these tools. We would be buying more of these tools if they were properly linked into the full tool chain. So, my first challenge, work to deliver standards quickly. I guess I've talked about the hardware verification languages, but we've had the same thing, CPF, UPF. You know, that was 2006, I think, when that really started, and it's only just coming to a conclusion now. Implement these EDA standards as soon as they're available. Get them in the tools quickly. I think UCIS, that started with a donation from Mentor in about 2008, but I still can't use it in the full tool chain now. It's out there, let's get it implemented. And then figure out how to innovate on top of those standards. That's where we will get most benefit, and that's where we're going to spend our money. So in my last few minutes, I'm going to move on to my second challenge. In IP to SOC verification reuse. So I'm an IP provider. Okay, I provide it within the company. Our IP doesn't get given to other companies, but I provide my IP to lots of different SOC teams within BROADCOM. Each of those SOC teams has got a different view about what integration testing means. There's, oh, I'm much more paranoid than you. Well, yeah, okay, but I've got a limited amount of resource. I can only support one set of integration tests. I can't go around creating a specific one for each of the different SOC teams. So what I propose is we get a standard industry-wide verification methodology, something above UVM that's all about integration testing, that figures out how to do maximum reuse of my IP level test bench into that environment, tells me the kind of stuff I should collect from a coverage point of view to show that I've done my connectivity testing right, and also supports some level of performance testing. I did want to elaborate on performance testing just briefly. So this is kind of a very rough and ready diagram of my flow, but I've started off spending a huge amount of time doing my IP testing. I get a robust IP. Then I move on to do my integration test. Whoops. Then having done all that stuff, I get an FPGA system, something on an Eve or a Palladium or a Velocity or whatever. I'm ready to go now, and then there's a massive gulf where I wait for my software guys to get the software up. And they're trying to boot Linux or Android. They're trying to get their drivers working. The customer's demanding something different, so they've refactored all their software. Several months later, they come back and say, we're only getting 1 frame a second. But back here, I've actually had everything I need to do at least some level of simplistic performance testing, so I can find those really stupid things. So some kind of early look performance testing. So I start with my UVM sequences. So they tell me how to control all my different IPs. I've got my SOC design, including some kind of ARM processor or something like that. Methodology, an EDA tool, and out the other side pops a load of C test cases use my FPGA hardware, and then I can do some early look performance evaluation. I can find the stupid things that lead me to the 1 or 2 frames a second before I've got all that software booted, before I've got all that software written. So my final challenge is to get an industry standard methodology for integration testing defined and adopted, and I'm sure somebody will write a book on it for us, and then a tool that takes those inputs and produces some performance level analysis at the SOC level.
Thank you very much, Chris.